Welcome everybody to this week's Code with Jason Meetup. Thanks for being here. We'll dive right in this time. This week we're going to talk about flaky tests. And before I start talking about flaky tests, I want to ask you guys who, by a show of hands, or you can type in the chat, who has dealt with flaky tests? Have you ever worked anywhere where you had a flaky test problem? Okay, Jonathan, Matt. Okay, nobody else? Well, hopefully this knowledge comes in handy anyway, because it's likely that you will. Okay, Ben says yes. Oh, capybara tests. I have a comment about that, but I'll save it for the appropriate time in the presentation. So yeah, I want to talk about flaky tests. I'll give a little bit of background why I've been thinking about this lately. So in October, I got a new job. And one of the things I was hired to do, for starters at least, is to help them with the flaky test problem they were having. And I'm not authorized to air their dirty laundry, so I'll be kind of vague. But suffice it to say, they had a serious flaky test problem and a lot of flaky tests. And so I got a lot of experience diagnosing flaky tests and fixing them. And so after I did that, I decided to write a blog post, which I'll share that right now. This talk will just be kind of the talk version of that blog post, as I often do in these meetups. But I decided to write a blog post kind of sharing some of my experiences. This blog post and this talk this evening, this is kind of narrow in scope. It's only what causes flaky tests. I don't plan to talk much about how to actually fix flaky tests, because that in itself is a big enough topic to justify its own separate thing. So this is only about what causes flaky tests. But before I even talk about what causes flaky tests, let's talk about what a flaky test is. Does anybody want to take a stab at it? Jonathan, I have a hunch you have a definition in your head.
Yeah, I'd say flaky test is one that sometimes passes, sometimes doesn't. Yeah, that'd be the core of it.
Yeah, and the only thing I would add to that is sometimes passes, sometimes doesn't, even when no application code or test code has changed. Yeah, so another way to put that is a flaky test is a test that's not deterministic. And deterministic, because not everybody's encountered that term, something's deterministic if giving the same inputs always gives you the same result every single time. An example I might use is, if you guys have seen the game Plinko on The Price is Right, Plinko is non-deterministic. If you put the puck in the same place every single time, it will come out in different places. And then I don't have an example of a thing that is deterministic, but something that always goes the same way. Yeah, so a flaky test is a test that's not deterministic. And as far as I can figure, that means either there exists non-determinism in the test or in the application code, or both. So it doesn't matter where it is, if it's in the test code or in the application code, either way, it adds up to non-determinism. That was an important realization for me. Jonathan, sleep 5 for the win. That was a realization for me, that the determinism could either be in the test code or in the application code. You know, we think of flaky tests as a flaky test, but it's not always the test's fault. Sometimes it's the application code's fault. Shout out to JB Rainsberger for helping me realize that. Okay, so flaky test is a test that's not deterministic. We're going to talk about a number of common, well, not even the common reasons. This, as far as I can think, is the exhaustive list of all the reasons for flaky tests. And if anybody knows of a different reason that doesn't fall under one of these categories, please let me know, because then I'll add it to this list. But here's the ones that I have. Race conditions, what I call leaked state, and I'll explain what I mean by that. Network / third-party dependency, randomness, and fixed time dependency. Those are what I think are all the categories of causes of flaky tests. So let's talk about this first one, race conditions. It took me a really long time to understand what a race condition even is. So let's talk about this a little bit, because this is maybe the most common cause of flaky tests. So it's worth really having a firm grasp on. And again, for a long time, I didn't have a firm grasp on it, but now I think I do. I came up with a couple analogies. So one, and again, this is all in my blog post if anybody wants to go read it later, but I'm just going to read it straight off my blog post, because why not? Let's say I'm going to pick up my friend to go to a party. I know it takes 15 minutes to get to his house, so I text him 15 minutes prior so he can be sure to be ready in time. The sequence of events is supposed to be 1, my friend finishes getting ready, and then 2, I arrive at my friend's house. So he gets ready before I arrive at his house, finishes getting ready. If the events happen in the opposite order, then I end up having to wait for my friend, and I lay on the horn and shout obscenities until he finally comes out of his house, is what I wrote in my blog post. So that's a race condition. And I added here that race conditions are especially likely to occur when the times are very close. So imagine, for example, that it always takes me exactly 15 minutes to get to my friend's house, and it usually takes him 14 minutes to get ready. But sometimes, maybe one time out of 50, instead of taking 14 minutes to get ready, it takes him 16 minutes to get ready. Or other way around, maybe it takes my friend 14 minutes to get ready, but one day I somehow get to his house in 13 minutes instead of 15 minutes. And so then the problem scenario happens that way. So I use those numbers, 14 and 16 minutes, to illustrate that it doesn't always take a very big deviation from the norm in order to give rise to these problem scenarios. So as far as I can think, and correct me if anybody has a different thought, but what I think gives rise to race conditions in programming is parallelism and sequence dependence. Again, like I got hung up for way too long on like big words. That's why I wanted to give this example of picking up my friend to go to a party. It has all the characteristics of a race condition without involving anything technical. So when I say parallelism and sequence dependence, okay, so the parallelism in the party scenario, my friend's getting ready for the party and I'm driving to his house. These two things are happening in parallel. And the sequence dependence is that we depend on my friend finishing getting ready before I arrive at his house. So again, don't get hung up on overly technical things like I did. Parallelism just means two things happening at the same time. Sequence dependence just means they have to happen in a certain order, or else there's a problem. So as far as I can think, it doesn't matter what form of parallelism two things take. It doesn't matter whether it's like a UI Ajax request type thing, or like multi-threading or something like that. It could be absolutely anything. It's immaterial what form the parallelism takes. The significant thing is that the parallelism is present. And I want to pause for a second here. because I honestly am not sure if I'm like stating the obvious. If anybody, can you type in the chat, did anybody just learn anything they didn't know before? Or is this all like review for everybody? Did you guys already know all this stuff? Or you can say verbally too if you want. Yes, it's giving me JavaScript fetch PTSD. Sorry to hear that. Okay. Anyway, not a lot of people, I like the example, simplifies it. Yeah, well, at least for me, that was, I found that helpful to like write all those things out, because like there's a lot of fuzziness around race conditions and stuff like that. Again, what even is a race condition? It helped me to pinpoint those things. Okay, so that's race conditions. That's one thing to keep an eye out for flaky tests. Oh, apologies, there's more. So I want to make a comment about race conditions in DOM interactions and system tests. So somebody had commented about, yeah, Ben had commented about capybara tests. Capybara gets a lot of blame for flaky tests, and it gets blamed for being slow too. But the thing is, it's not that capybara is flaky, it's that you're using capybara in a kind of test that is susceptible to race conditions. So again, what gives rise to a race condition? Parallelism and sequence dependence. You just don't have as much of that when you're dealing with model specs. But once you involve the DOM and AJAX calls and stuff like that, you have more parallelism and sequence dependence. So it's not capybara's fault. Capybara is not flaky. It's just that in these kinds of tests, you have more chances for race conditions. And if you used a different tool for the same kind of tests, you'd still have flaky tests. So it's not capybara's fault. It's your fault, dear programmer. You wrote these flaky tests. But we'll talk about how to not at some point. So I want to tie this to an example. I want to tie a DOM interaction example to my pick up the friend for the party example. Let's say, and by the way, I hope there's somebody else who's just silently as dumb as me, because nobody said that like, oh, this is news to me. So I'm sure at least even somebody watching this is news to them. Anyway, let's say there's a test that submits a form and then clicks a link on the subsequent page. Submits a form, a second page loads, you click the link on that second page. To tie that up to the analogy where I pick up my friend, the submission of the form would be analogous to me texting my friend saying I'll be there in 15 minutes. And then the loading of the subsequent page would be analogous to my friend getting ready. And the race condition would be when the test execution attempts to click that link on the subsequent page before it appears. I've arrived at my friend's house before he's ready. So I'll say that all again. Submitting the page is analogous to me texting my friend saying I'll be ready in 15 minutes. The subsequent page loading is analogous to my friend getting ready. And then I'll say it in a slightly different way. The loading of the page is analogous to the point where my friend finishes getting ready. The page is ready, my friend's ready for the party, same thing. And then the clicking of that link is analogous to me arriving at his house to pick him up. If it's not ready, there's a problem. I'm just looking at my notes. Bear with me a second here. Okay. Yeah. Not to put too fine a point on it, but the last analogous part is that failure where the test tries to click on that link before it's present and then it fails, that's analogous to me like arriving at my friend's house before he's ready and saying, oh, he's not ready, and then I just drive away. That's analogous. And then we have breakage. And so the solution to these kinds of race conditions is to just remove the asynchronicity. And instead of allowing the test to execute at its natural pace, you add a step where before you click that link, you assert that there's some text present on the page or something like that. This is something very common that I do a lot. And it's a failure scenario that I see a lot. One action is taken, then another action is taken. There's a race condition there. So I insert a step in between those two things that says, do something to make sure that that subsequent page is loaded or whatever it may be. Usually it is a subsequent page that gets loaded. And I just assert for the presence of the H1 on the page or something like that. And that stops the race condition. Okay. Yeah. And, we talked earlier about the, like, sometimes it takes my friend 14 minutes. Sometimes it takes 16 minutes. And if it always takes me 15 minutes, then sometimes he's ready and sometimes he's not. So this is like an edge of timeout race condition. And in those cases, sometimes you can just increase the timeout. So this might be analogous to me, like maybe my patience for my friend is 1 minute. And if it takes my friend 17 minutes to get ready and I get there in 15 minutes, if I'm only willing to wait 1 minute and then I leave, then that's a problem. But if I decide I'm going to be more patient in general, I'm going to wait 5 minutes instead of 1 minute, then because my patience level exceeds the variation in the amount of time it takes my friend to get ready, then we never have a problem anymore. So again, the analogous thing is if there's some kind of timeout, you can increase that timeout. Sometimes that's just a Band-Aid and you're not really addressing the real solution, but sometimes that's fine. Sometimes Band-Aids are fine. And you can do that timeout increase on a test by test basis. You could do it globally, whatever you think makes sense.
It's one thing maybe worth mentioning with Capybara, what it's actually doing behind the scenes when you're checking for the H1 is it's checking for the H1 and it fails, and then it checks again and it checks again and checks again in that timeout until it stops failing. So you're actually you still have a flaky test. It's just that it's intentionally flaky. So it kind of masks those failures within that timeout.
I see. Okay. Yeah. And not that anybody asked for more analogy, but that's like saying, hey, you ready yet? You ready yet? You ready now? Okay. So that's all for race conditions. Unless anybody has any more questions or comments, I would love to talk more about race conditions if anybody wants to. Does anybody have anything? Okay. So yeah, that's all for race conditions. Now let's talk about leaked state. So here's what I mean by that. I'm going to illustrate this one with an analogy also. Let's say I want to perform 2 tests on myself. One is a test to see if I can shoot an apple off of, let's say, Carl's head with a bow and arrow. And the other test I want to do is to see if I can drink 10 shots of tequila in under an hour. If I were to, for example, perform the arrow test where I shoot an apple off of Carl's head once a week, immediately followed by the tequila test, we get together and we do this every Saturday, it would always be fine. But if I did it the other way, these 10 shots of tequila might compromise my aim, and then I might miss the apple. And sorry for your luck, Carl.
At least I wouldn't feel it, I guess. So that's good.
Oh, I don't know. I might shoot you in the leg, But the point there is that one of the tests, it affected the global state, it leaked state. So when I drank the tequila, I got drunk. And so that affected the way that the other tests go. And, you know, if you didn't know much about the situation, you would see, okay, so think about this. Me and Carl get together once a week. I shoot an apple off his head. I drink 10 shots of tequila. But then one day, for some reason, we do the tequila test first, and then we do the arrow test. Where does the problem become noticeable? During which test does the problem become noticeable? During the arrow test. And so the arrow test fails. The tequila test passes. I drank those 10 shots of tequila just fine, no problem. It was the arrow test that failed. And this creates a very misleading situation because somebody sees that and they say, the arrow test failed. The arrow test is flaky. There's a problem with the arrow test, which is false. There's not a problem with the arrow test. There's a problem with the tequila test. And so that's something that creates really tricky situations, as you can imagine. Just curious, have any of you guys encountered a flaky test like that before, or is actually there was no problem with that test? It was some other test that was causing the issue? Yeah. Yeah, so that's what I mean when I say leak state. So here's a few ways that actual tests can leak state. One way, for example, is to alter database data. Let's say that you have two tests. One creates a user with an email address, test@example.com. And let's say there's a uniqueness constraint on that field. Well, you can imagine if there's another test later that also creates a user with test@example.com. There would be a collision and that uniqueness constraint would fail. The second test would fail, even though the problem originates from the first test. We're polluting the database data. Similar things can happen with configuration settings, environment variables, altering the contents of the file system, any other number of ways. So again, this is kind of like the race condition thing. Like, forget about the technical details. Those are incidental. The significant thing is that some state about the global system, the environment, that kind of thing, something's leaking out of the test and persisting beyond the end of the test, and that causes a problem in some other test afterward. It's immaterial exactly how. So conceptually, it doesn't matter. Conceptually, the only thing you need to know is that the state leaks somehow. Any questions or comments about leaked state before we move on? Okay, these causes get simpler and simpler, so they'll be shorter and shorter. Network and third-party dependency. The main reason why network and third-party dependency can cause non-deterministic behavior is very simple, which is that sometimes the network works and sometimes it doesn't. And there's not, everything else is kind of maybe just a detail, but when you're depending on a network, you're often also depending on a third-party service. And so even if the network's working just fine, there's no problem with the internet, there could be a problem with the third-party service. The Stripe API goes down, something like that. Or, you know, a lot of times we work with less reliable services, some no-name service, and that's just, or it responds in a weird way or something like that. It's just not very reliable. So if you really hit the real API in your tests, then you're going to you're going to get that non-deterministic behavior once in a while. So obviously, I mean, I shouldn't say obviously, but the thing to do in those scenarios is don't hit the API in your tests, mock out those API requests and responses, because the thing you're interested in is your application's behavior. How does it behave under a success response, a failure response, etc.? We shouldn't be making these actual API calls because that makes our tests fragile and, again, flaky. Okay. That's API and third-party dependency. Now let's talk about randomness. We're on 4 of 5 right now. So randomness is by definition non-deterministic. To use a really simple, obvious example, if you generate a random number that's either 1 or 2, and then you assert that it's 1, that test is going to fail about half the time. The way that this comes out in tests a lot is people have a list of something and then they order that list in a way that's random or not guaranteed to always be the same. And so then you say, get me the first item on the list and the second item on the list and assert such and such. Some portion of the time that fails. So the solution to that is whenever you can, don't do like dot first in a test or whatever. Grab definite things, find things by their attributes rather than finding them by order, stuff like that. Try not to do things in ways that are susceptible to randomness. Last item, and this is almost a peripheral one, but it does happen. And that's fixed time dependency. So one time I was working late. It was like 9 p.m. Eastern time or something. And I had never, at this particular job, I had never worked that late before. And at some point in time, my test suite started failing. I couldn't figure out why because nothing had changed. After a while, I realized that I just never ran the test suite that late in the day before. And there was something in my tests that only worked before 9 p.m. Eastern or whatever the threshold was. So to use an example, this one's it's mind bending. So I need to refer to my example from the blog post. I think the common case is a test that crosses a boundary of either a day or a month or a year, something like that. So let's say you have a test that creates an appointment that occurs 4 hours from the current time. And then it asserts that that appointment is included on today's list of appointments. So the appointment occurs 4 hours from now. We assert that it occurs on today's appointments. That test will pass when it's run at 8 a.m. because 4 hours from now is 12 p.m. That's still the same day. But then if you run the test at 10 p.m., 4 hours from now is 2 a.m. the next day. And so it won't show up on today's appointments. So that's an example of fixed time dependency. Yet another thing to watch out for. So I'll say again, I think, if I'm not mistaken, I think that's an exhaustive list of all the categories of causes for flaky tests. If anybody's able to tell me different, I would love to hear it because I do want this to be an exhaustive list. Anyway, that's my presentation. Let's open it up for questions and discussion and all that. Does anybody have any questions or comments?
I was just gonna say, I've done a lot of things with annual renewals, and especially on like trying to test those things on like February 29th in particular can be fun.
Oh yeah. Yeah. And by the way, as a lot of you guys probably know, it's a solution to that is don't depend on like the current actual time, but like use travel to or whatever to go to, okay, let's go to February 29th and do what we need to do on February 29th, blah, blah, blah. Yeah, I know obviously I'm preaching to the choir with you, Carl. Yeah, but that's the kind of thing that's bitten me a few times. Yeah. Okay. Well, sounds like there's not a lot of questions today. Do you guys have any ideas for future meetup topics? It's a bit of a quiet group today. Okay. Well, I will, I'm going to take a peek at the schedule real quick for the meetup, so I can share what's coming next week. Next week, we're going to be talking about abstraction. And by the way, I want to add that soon, I think I mentioned this last time, but soon I'm going to be adding a European friendly meeting. So Code with Jason Meetup will meet twice a week instead of just once a week. That starts in like April or May is when I'm going to start that. Okay. We do have a couple ideas for future meetups. Mocks and stubs. That's a great one. Yeah, I'll add that to my list, mocks and stubs. Oh, still curious about structuring APIs and using APIs. I do have that on my list, Ben. Thanks for the reminder. That bumps it up on the list. Webhooks. Okay. Ranjan, you mean just like threading in general?
Yeah, with the trading in general and like how we can test those trading.
Okay. That'll be an interesting one. I don't have much experience, but I'm always happy to dive in and learn about things so I can present. Okay, well, bear with me for 2 seconds because this Zoom chat always goes away. So I'm going to take notes. Mocks and stubs, APIs, and then webhooks and threading. Okay. All right. Well, I guess today's a little bit of a shorter one, but I hope you enjoyed today's presentation. Thanks so much for coming, and I will see you guys next time.